Well, thanks for joining us again for the next in this series of coding and marking panels. Today we're going to be looking at the Rotec feeder range and talking a little bit about how it's evolved over the years. And with me today, once again, I've got Peter Lisher, who's our development manager, and Miguel Mari, who's one of our development engineers. What we're going to look at is basically how the range has evolved from where we started with the RF1 feeder some years ago and how that progressed on to give us next the RF2 as we were looking to reduce entry-level costs for our customers, and how that developed on to the really successful RF Lite, which really made inroads into the market and almost set up a market in its own right for a very cost-effective system for the date coding of food sleeves. Once we got to the RF Lite, which was primarily for food sleeves, we realised that there was still that demand for things like food pouches and larger format packaging materials. And that brought us on to a system which used the same principle as the RF Lite, which was the RF Auto. And that has a unique, patented gating device that allows it to cope with a wide variety of different thicknesses and different formats of packaging. The RF1 was also the starting point for machines that we added to. So with the RF1 we realised that we could add things like cameras and reject devices to provide the pharmaceutical industry in particular with a system where not only would we feed and print a carton, we would check it with a camera, and then if it failed on the camera we could reject it into a reject bin. And that gave birth to the range of products called the RF Compliance. And then finally, again, moving on from that core machine of the RF1, we developed the RF Case, which was really two conveyors put together to give us a feeding system for flat cardboard boxes. And then more recently, a range of conveyors in their own right, as we have things like large area printers where customers want to transport their product past the printer. We've developed a flexible and innovative range of conveyors which allows us to present the box, the product, to the printer in a very controlled and stable fashion. So that really is the overview to what the following videos are going to cover. As I say, starting with that core RF1 machine and then how the product range has developed on from there. In looking at the history of the current Rotec range of feeders, really a good place to start is the RF1. The RF1, as you see it here, was launched at the PPMA show in 2009, along with the two other variants, the shuttle feeder and the pick and place vacuum feeder, which we now call the RF pouch. The roots of this machine go back a little bit further, about 6 years previously, to the predecessor to the RF1, which actually looked very, very similar. We called it the Feeder 250, but in principle it was pretty much identical. One of the key things about the feeder was that we felt we employed for the first time the idea of a conveyor belt which acted not only as a transport device for the product, but also acted as a printer platen when fitting a thermal transfer printer. And this came out of an inquiry from a seed packer who wanted to take a seed pack but print a very large and particularly very long format on the pack. And at the time, a thermal transfer printer, in fact today, a thermal transfer printer that prints intermittently will only sweep through about 4 inches or 100 millimeters, and that wasn't enough for their requirement. So the idea was that if you could run a thermal transfer printer in its continuous mode, you had no restriction on the length of the print format. So that's how this system was born. Underneath that conveyor belt, which is not only the product transport but also the print platen, is a standard rubber platen roller that you normally see on a flow wrapper when a continuous motion thermal transfer printer is fitted. So between the two, that gives the printer the sort of surface it is expecting to print down onto. And when you look at this print head here, you can see that it's pretty much in line with the crown of that roller, so it's set up just as it might be on a flow wrapper. So that really gave us the advantage that we could now feed product and print it at the same time, so we had no restriction on print length. Thermal transfer printers came in 2, 4 and 5 inch widths, so we had a very wide print area available. And also, because we were printing while the product was moving, the throughput was good. The speed of the belt didn't seem very fast, but when you saw the packs dropping off the end of the belt, you could see that they were actually running at quite a speed. That, coupled with a PLC control system, which meant that we saw the product arriving on the conveyor here, and then monitoring that product in the PLC to the point where we needed to trigger the printer, gave us a system which was very robust in terms of the range of products it could handle, and made the system independent of any sort of surface finish on the product. Trying to see the product at the printer against the belt could be unreliable. Seeing it at this point against a reflective pad was completely reliable.
You said that you came up with another 2 versions, the shuttle and the vacuum.
That's right.
And you're talking about how it was robust. What are the reasons why you made these other 2 variants? For what kind of samples did you want them for?
Okay, well the friction is probably the most universal system because it can handle anything from a sheet of paper up to a carton. But when cartons get very small and narrow in the direction that they're travelling, the distance between these feed rollers becomes critical. So in the case of this RF1 friction, once you get below about 2 inches or 50 millimetres, the product is likely to drop between the rollers. The shuttle version overcame that because the shuttling plate of that system could take a very narrow carton, because instead of this angled friction feed, we've got a flat bed with a reciprocating plate, and that pushes the carton forward, again under these same nip rollers, and then same principle again going down to the printer. The pick and place, the RF pouch, was really for the products that we couldn't feed on either the friction or the shuttle, so that tended to be bags and pouches and that sort of thing. And again, we picked them, put them on the same conveyor, and then ran them down in exactly the same way.
Yeah, I was just going to say on the pick and place or vacuum system, I think I joined Botec in 2011, and it was going from quite a spate of vacuum machines going out, but they had to all be customised to pouches, zip pouches, bits and pieces. So one of my first jobs when I joined was to customise it for a company making carp food for fishermen.
Okay.
So that was quite interesting. That was quite a challenge. Quite a range of bags to be fed. They had separate jigs, so it was quite interesting. Lead into Rotec, I'd say.
Was it just a standard machine that had customizations on it?
It's just a fairly standard machine with customisations. We had to do quite a bit of work with the vacuum system because some of the pouches were quite large and required a little bit more vacuum than maybe the standard system did. So that was kind of my introduction to Rotec and pick and place machines.
Yeah, remember them well. The same customer's gone on to have another system, and in fact the very first customer we built the very first one of these systems for what must be about 17 years ago now, upgraded to an RF1 probably 4 or 5 years ago. So it was nice to have the continuity going through there from the very first customer still using the same principle but with an updated feeder and printer. So here we've got an RF1 fitted with a thermal transfer printer, the original setup that this configuration was designed for. But of course the feeder can have a range of printers and labellers fitted to it, and in particular you could fit a thermal inkjet printer onto the RF1 so that you can print using that technology for something like a data matrix barcode onto a carton, or even just a use-by date onto a food sleeve.
But if you fitted a thermal inkjet printer that's quite small, isn't there a lot of area on the conveyor for a small printer?
Indeed there is, which is sort of leads tidily on into where we went next after the RF1, because exactly that argument was that you're wasting quite a lot of space for a printer that's only sort of taking up that length on the conveyor. So brutally, I suppose, to describe what we did, was we chopped the machine there, we lost the conveyor, and we took the feeding head and enclosed it into a standalone system which we imaginatively called the RF2. The RF2 was just basically the feeding head, and then it effectively spat the product, more often than not a food sleeve, forward under the nip rollers, and below the nip rollers, instead of the conveyor roller, there were another set of rollers. So it spat the product forward, and then as near to these rollers as we could go, there was the TIG print head, which would print the product while it was still flying horizontally and before it fell away. And that was quite a crucial development, because that was reducing the entry-level cost for a customer looking to do typically date coding of food sleeves. So the less expensive feeding system with a simpler TIG printer was starting to dramatically reduce the entry-level cost for a date coding system, quite typically for food sleeves.
Following on from that, of course, we went to looking at what we call the RF Lite, which was pretty much the next step, which is instead of floating the product past the print head, we actually moved it onto another conveyor, which wasn't actually at 15 degrees, so we're not bending components through or products through 15 degrees, but feeding them straight out. We had another set of TIG printer mounted right in front of it, and keeping everything flat and keeping the throughput.
Well, that's right. There were sort of two threads going there. The first one was that we could see that by reducing that cost, we were increasing market share and producing a system which was appealing to our customers because of the lower cost. And as Peter says, we recognised that it would have been ideal to keep the product running on a belt of some sort past the printer. And that's how the RF Lite was born.
Was the main purpose so that it doesn't bend in the transition? Or was there other reasons why you decided to go for belts helping it through?
Mainly, I would say it was not to bend it, but also it just made life easier to keep everything running in one plane. Now, as it happens, we've got one we made earlier. And so this was where we moved on to with the RF Lite. So you can see common themes between RF Lite and RF1. In particular, we're using the same rubber feed roller. We're using the same gating finger as on the RF1. So the technology from here has been transported over to here, but in a much simpler, much lower cost feeder, where we can add the thermal inkjet printer on here. We can't add a thermal transfer printer, that's why we still have the RF1, but the thermal inkjet printer can be added here. And then we've got this run-out section here of belts where the product is being presented flat to the inkjet printing head, so that you get a nice presentation to the print head, and therefore you get a perfect print.
Yeah, the spec for the RF Lite was very tight, even down to the fact that it had to be shipped in a case which parcel force would take maximum dimensions, maximum weight, and the idea was that it could be packed, everything's in the box, and it just works straight out of the box. So I think we started development on this in 2014.
Yeah.
Late 2014. Sold our first RF Lite in 2018, I think February. And to date, it's proved very successful. I think we're over 200 units sold now. So
yeah, comfortably.
It's been, so at the time it was quite a challenging spec, but I think we kind of achieved what was required, and it's been a very staple product for us.
Yeah, that compactness has paid dividends in several areas. Obviously, you know, from cost, but also, as Peter said, the fact that you can ship it around easily means that we can even run a service exchange system, that if somebody has a problem with a machine or it just needs a service, they can get a service exchange system overnighted to them, and then they can move their printer over and send the other one back, and then we refurb that and put it back into the pool of service exchange units. So RF Lite's really transformed the market for us. It's generated a market for these types of systems.
I know you said that it's fairly standard. Have we not actually modified many RF Lites? Because you said it works right out of the box, so do we not really do modifications on this?
It's to quote another manufacturer, it does what it says on the tin. There are virtually no modifications. I mean, we may do a couple of bits and pieces, but in the main, the actual products stay the same. We've had to make changes to fit different printers instead of TIJ printers. Some people wanted a CIJ printer, so we had to make changes to the guarding or the gantry that holds the printing to fit that.
Okay. The key, given the cost, is that it's a standard product that ships as standard and does what it does. What it does really well. What it doesn't do. But there's other products in the range that will. I suppose one development we brought along, which was again using the technology of the shuttle feeder of the RF1. We have got a variant of the RF Lite which has got the same idea of a reciprocating shuttle plate. Again, for those small cartons, although we often say it's a date coding system for food sleeves, we recognise that it will feed a carton. It has applications in cosmetics and pharmaceuticals, and if those products are small, then a shuttle system is ideal for that, and we have produced a shuttle variant of it. We've described how the Rotec range of feeders evolved from the RF1 some years ago, and how that moved us towards the RF Lite, which has become our top-selling feeding system. The RF Lite we bill as being a date coding system for food sleeves, but obviously there's requirements to do more than just feed food sleeves. And we went on to develop a slightly larger version of the RF Lite, which we call the RF Auto. The reason it's called an Auto is that it has a unique patented gating device for feeding the product out of the hopper. And as Peter was very instrumental in the design of that, he can probably describe it a little bit more.
Yeah. The challenge, I think the challenge we were faced with is how to feed a variety of products, from maybe thin blister cards up to crash lock cartons, and then you've got pouches where you've got additional features on the pouches of zips, and our standard sort of manually adjusted gating finger just wouldn't cope with all of those. So what we were looking at was a system where you could just literally put any product into the hopper, and the gating system would then just allow it to feed through. Took quite a long while. We came up with if you like, a gating wheel. So the gating wheel springs on an arc, allows the unit to come through, and as it comes back, it nudges the next one in line back a little bit to allow a gap, which is then taken onto a second conveyor, or the outfit conveyor, and then it allows the gap. So the gating wheel will adjust automatically to pretty much any sort of product. The other issue we had, or we were looking at, was, generally speaking, the RF Lite and the RF ones all have sort of wheels on top of them to keep the product under control. So we looked at using a vacuum system to actually hold the product down and keep it on the bed to transfer underneath the printer. That again was another, not so much a challenge, but generally speaking, vacuum systems use three-phase vacuum pumps, which are very noisy, very expensive. And we looked at introducing our own little vacuum chamber using electric fans. That seems to be pretty successful, and I think we've moved on from that. And so we've now got the advantage of the RF Lite, which is a straight-through system from the hopper onto the belt and out again. So I'm not trying to bend the product through 15 degrees to get it out. And again, got the versatility of the machine with our sort of hopper system, drive belt in feed, and vacuum belt out feed.
I suppose, as well as it being larger, being able to feed more variety of cartons, we are able also to put multi-headed printers on it, which we couldn't do on the RF Lite.
Yeah, and of course the Auto is the first machine that we can effectively fit a labelling head to. because the conveyor on the outfeed is that bit longer. As you say, it will allow you to put a multi-head printer on there, or indeed a fairly compact labeler, but we've got a number of RF autos that are doing labelling applications as well. So I guess really that in a nutshell is the RF auto and how it came to be and how it evolved on from our ever popular RF Lite. We've looked at how the RF1 evolved to give us what today is the RF Lite and the auto range. The RF1 was also the core machine for us for developing on from that to give us the RF compliance. This is a system where we were being approached for a solution for not only printing a carton but also inspecting it and then rejecting any product that didn't pass the camera inspection. So the idea of adding a camera on was fairly simple. We had the length of conveyor already on the RF1, but then of course we had to handle reject. Reject with a belt stop is effective, but rather clumsy. So we wanted to look at some form of reject where we could get just one reject off the system without stopping the run. So we came up with a diverter flap reject system. And Peter, you can probably describe a bit about how we got the drive of that running.
Yeah, as Richard said, if you use a belt stop, it just stops the flow of the product coming down the line and reduces your throughput. So what we looked at, and we went down quite a few avenues before deciding on this idea, was that if we could pick up the drive off the end of the outfeed conveyor, and then what we could do then is just have a dancing arm, which would just, when it's rejected, it keeps the product down, but then the flap comes up underneath that arm to allow the product to drop into a tray. And the advantage of this, of course, was that we didn't need any additional drive systems. It was all taken off the existing conveyor. The actual reject unit was very easy because it rejected it into a bin, not having to take it off somewhere onto another system. And all told, it was a very straightforward, if you like, adaptation to the RF1 in order to get the reject working.
Yes, that's right. And then we married that up with a shingling conveyor so that the good product carried on and was easy to scoop off at the end. And the compliance as we see it today has been redesigned into one chassis, whereas it was an RF1 with additions. The compliance is now one chassis. Obviously, this was for primarily pharmaceutical use, where data matrix barcodes were becoming more prevalent on packs. That data matrix barcode originally was just holding fixed information or information which stayed the same for the batch, and typically that was the GTIN number, the lot number, and the expiry date. But of course, that's evolved on with the Falsified Medicines Directive to require serialization of packs. And Miguel, you've been quite involved in the solution we came up with there for serialization.
Yeah, we made a whole system that would serialize cartons as they print on it. So we were able to put a printer and a camera on it, all linked up. You can even link up to the servers of the customer.
Yep.
So both the printing and the verifying can all match up with the records that they have. Right. So database printing has been really useful at that. And of course, if any print is incorrect, the whole reject system also helps with that to make sure that there are no incorrect products that can go through, because it's very critical, obviously.
It's quite interesting. You can actually set the number of rejects. So if there's more than 3 rejects, you can actually stop the whole system because there's clearly a major malfunction.
Yeah,
I think it's normally 3 you set.
Yeah. Normally 3 consecutive, and you stop. It is adjustable, and obviously because it's a compliance system, there are sometimes different requirements from different customers, but we can easily accommodate those with the programmers of the PLC systems that are controlling it all. And as Miguel says, we can interface to an external database if we're required to do the serialization aspect of it. So the compliance really is a sort of flagship machine for us, and very adaptable to any range of printer or camera that the customer may wish. The clever stuff is all in the feeder base. Cameras and feeders can be added as required. The Rotec RF1 was the core machine that led us on to other developments such as the RF2, the RF Lite, and then the RF Auto. But a slightly different route led us to another machine called the RF case. Now this was really born out of a request to be able to put a fairly large labelling system onto the feeder, but also to be able to handle a much larger product than we would run on the traditional RF1. And in this case, an outer case or an outer box, typically a flat brown cardboard box. So this uses the same core conveyor components as the RF1. And in fact, there's two of them, an in-feed conveyor and an out-feed conveyor, and they run at slightly different speeds so that we pull a bit of a gap, and then that gap can be seen by a sensor. And in this area, a printer, a labeler, or whatever can be fitted. So many similarities to the RF1, same conveyor construction, but for larger boxes. And I think, Miguel, this is one of the first ones you came across when you joined us, wasn't it? An RF case.
In fact, it's funny you say that they're made for labelers, because the first one I worked on actually had a labeler on it. It was my first project that we worked on, and where we were labeling onto whiskey boxes, actually. And they were quite prestige whiskey boxes, so they required that the label was put on plus or minus 1 millimeter in any direction. So it took a lot of fine tuning, but we managed to get them all to feed quite well and labeling within their tolerance.
Yeah, I think a lot of that came down to the fact that we had a laser sensor here, as we've got on this one, so that we were seeing the leading edge of the box at this point, and then the label was only sort of here. So there was very good control between the trigger and the label point. Exactly. We didn't run very fast, as I recall. They were quite happy to go at quite a modest speed because the accuracy was everything.
Yeah, we found the kind of speed range of this is probably top speed of about 18 metres a minute, which is enough for somebody to load and remove product. So any faster than that, and it's just not really operator friendly.
Manageable.
Manageable. Yeah. I mean, one of the things with the machines, we found that it is quite flexible in terms of what people want to do. I mean, when you look at a box, it might always look that big, but when you flat pack it, it suddenly grows in its length and its width. So you could end up with a box which could be 800 millimetres long. So this machine will go from round about 300 by 200 up to, in this case, this machine is a 500 wide system, up to 750. But we can go wider. I think the widest one we built is 700 millimetres wide and almost 1100 metres long box. One of the things there is, of course, once you get to that sort of box, which I think was actually a 12-inch pizza box, which was flat packed, and was then taken on to, we had to have two machines in a row, and then the box was taken through, and it was 4-colour 3D printed as the logos that went through. So we actually had two of these machines in a row, and belt transfer all the way along, plus a collection on the end. So it was getting quite lengthy at the time.
Yeah, I think, and I remember that.
I think it was nearly almost 5 metres, wasn't it?
Almost 5 metres,
It occupied most of the factory behind us when we built it.
Yeah.
Yeah, so that's really the overview of the RF case. Larger boxes lends itself very well to labelling or to any sort of printer. Could even be one of the large area printers that we offer, the Seiko head printers, which can print down onto the box if you want to do a direct print rather than a label. Very modular, certainly can grow in terms of length and width to accommodate the product range. And that really is the RF case. Well, thank you for watching our videos. I hope you can see how our range has evolved over probably a space of about 12 years from our core RF1 feeder, and how we've taken that on to give us the range of feeders we've got today. Still, of course, the RF1, but also the RF Lite, the RF Auto, the RF Compliance, and the RF case. And we are always developing. So do keep watching our videos. Do please keep looking at the website. There's always innovation happening at Rotec, and we're always happy to hear about new applications that our customers require. So thanks very much for watching. From Peter, from Miguel and myself, Thanks very much, and we hope to see you again in one of these videos. Thanks very much.